హలో.
హలో మురళి.
హాయ్ అన్న, గుడ్ మార్నింగ్. అదే మళ్ళీ ఏదో కనెక్ట్ కాలేదంట ఊర్లో.
ఏం కరెక్ట్ కాలేదంట?
నెట్వర్క్ క్లాసు
ఎందుకు అవుతుంది?
నెట్వర్క్ చూపించలేదు. హాట్స్పాట్ ఆన్ చేస్తే అవుతుంది ఊర్లో అవుతుంది.
ఊర్లో బాగా హై స్పీడ్ వస్తుంది.
ఊర్లో ఇంకా ఎయిర్టెల్ ఇంకా స్పీడ్.
నేను ఊరికి వస్తే వర్క్ చేస్తా కదా, వర్క్ ఫ్రమ్ హోమ్.
అప్పుడంతా ఊర్లోనే కదా చేసింది.
అవును. చూద్దాం ఒక 5 minutes.
ఓకే.
వినపడుతుంది మురళి? మురళి, రైజ్ యువర్ హ్యాండ్. వినపడట్లే.
హాయ్ అన్న.
మురళి, ప్రీవియస్ లాగిన్వి తీసేసినాం. మళ్ళీ ఇవి ఏమైనా డివైస్ ఇష్యూ ఉంటే లాగిన్ అవుతుంది. ఇంకా వేరే ఉంటే మళ్ళీ చూసుకోవాలి. మన తరఫు నుంచి ఇదేం లేదు.
ఓకే.
ఇవి చూసినావా మురళి మొన్న నేను చెప్పింది?
ఇది ఎక్సెల్
ఓఎస్ కాదు కదా, ఓఎస్ఐ లేయర్ ఇవన్నీ నిన్న మనం డిస్కస్ చేసినవి.
చూసాను.
అయ్యా అర్థమైనాయి అవి?
అంటే వయసు వెళ్ళారా? అర్థం.
ఒకసారి పింక్ చేయి మళ్ళీకి.
చేసిన
ఇప్పుడే సేమ్ అదే ప్రాబ్లం అంటే ఇంకా
మీరు స్టార్ట్ చేయండి అంటున్నాడు.
స్టార్ట్ చేయనంటున్నాడా? స్టార్ట్ చేసి మధ్యలో వచ్చి కూర్చుంటే కష్టమే. ఎక్కడ అర్థం మొన్ననే అసలు వినలే. మళ్ళీ ఫస్ట్ 3 వింటే ఆ తర్వాత 3 అర్థమవుతాయి.
ఓకే ఓకే. కాల్ చేస్తావన్నా నువ్వు?
నేను చేస్తాను, ఒక నిమిషం మ్యూట్ చేసి.
చెయ్యి.
Is not answering. Please.
నేను అప్పుడేం ఆన్సర్ చేయలేదు మళ్ళీ.
ఓకే.
సరేలే, మనం ఏం చేద్దాం ఇంకా.
అదే వీడియో చూడొచ్చా అని అడిగినాడు అప్పుడే.
వీడియో చూడొచ్చు
కానీ అది లాగిన్ కావాలా దాంట్లో యాప్లో.
దేంట్లో?
ఇప్పుడు ఇక్కడ లాగౌట్ చేస్తామా ల్యాప్టాప్లో, కానీ మొబైల్లో లాగిన్ కాలే.
ఏం ఎర్రర్ ఏమొస్తుంది?
అదర్ అనదర్ వన్ సిస్టమ్ ఈజ్ యూజింగ్ అని వస్తుంది.
ఓకే, అప్పుడు ఏం చేయాలంటే దీంట్లో లాగౌట్ తీసేయాలి.
తీసేసిన
ఆ,
కానీ అట్లా చూపిస్తాను.
అవునా? అట్లా నువ్వు లాగిన్ అయ్యే ముందు ఒకసారి చెప్పు, నేను క్లాస్ అయిపోయిన తర్వాత రిమూవ్ చేస్తాను ల్యాప్టాప్ది, తర్వాత దాంట్లో లాగిన్ చేస్తాను.
నాకు అవసరం లేదు అట్లా, ఎప్పుడన్నా అవసరం అయినప్పుడు.
అట్లానా? నాకు ఒకసారి చెప్పు, అట్లా నేను చూస్తాను ఇక్కడ.
ఓకే, పర్టికులర్గా చెప్పాల్సిందే కదా అయితే?
అవసరం లేదు, మామూలుగా అయితే లాగౌట్ చేసి లాగిన్ చూద్దాం, ఏమైనా ఇష్యూ ఉంటే చూద్దాం.
ఓకే, అదే రెండు దాంట్లో యాక్సెస్ ఇస్తే బాగుంటుంది.
ఆ రెండు రాదు, ఒక చోట
ల్యాప్టాప్లో వీడియోస్ వచ్చినా బాగుంటుంది.
అది మొబైల్ యాప్ అనమాట.
అది మొబైల్ యాప్. ఓకే ఓకే, సరే సరే.
లేదంటే చూద్దాం, యాక్సెస్ 2 ఇస్తాం, పని అయిపోతుంది. ఈ క్లాస్ అయిపోయినా ఒకసారి గుర్తు చేయి.
ఓకే.
యాక్సెస్ 2 ఎవరు కొట్టుకుంటున్నారు?
నేర్చుకుంటాను.
పీజీలో చిల్లర నాయలు ఆడిషన్. ముబారక్ వచ్చేసిన ఏడున్నావు ఇప్పుడు? నువ్వు బెంగళూరు ఉన్నా?
బెంగళూరులోనే ఉన్నా.
వచ్చేసిన ముబారక్?
రాలే ఇంకా.
ఎప్పుడు వస్తాడంటే?
టుమారో కానీ డే ఆఫ్టర్ టుమారో కానీ రావచ్చు. నీకేం కాల్ చేయలేదా?
లేదు, చేయలేదు. సరేలే, మనం కంటిన్యూ చేద్దాం.
ఓకే
ఓకేనా? సో ఓకే, సో మళ్ళీ లాస్ట్ క్లాస్ we started OSI layers. Okay.
ఓకే.
OSI layers. So OSI layers we completed physical layer, right? And
No, OS logo is behind the class.
లోగో ఇంకా చూపిస్తుందా?
లోగో చూపిస్తా.
చూపించకూడదు అది. ఇది గ్లోకల్ సాఫ్ట్ లోగో అట్లా చూపిస్తుందా?
అదే చూపిస్తాను. ట్యూటర్ హ్యాస్ టర్న్డ్ ఆఫ్ దేర్ వీడియో అని చూపిస్తాను.
అవునా? ఒక నిమిషం స్టార్ట్ చేస్తాను. ఇప్పుడు స్క్రీన్ షేరింగ్ పోయింది కదా?
స్క్రీన్ షేరింగ్ పోయింది, లోగో అట్లా ఉంది.
ఒక నిమిషం. ఇప్పుడు
లేదు, లోగో అట్లా ఉంది, స్క్రీన్ కూడా ఉంది. నాకు క్లియర్
పోయింది కదా? ఓకే, రైట్ మురళి, కనిపిస్తుంది కదా స్క్రీన్? రైట్. సో లాస్ట్ సెషన్ we started with the OSI layer, completed physical layer, presentation and session layer and transport.
Okay.
Right. So these 4 we completed.
Yes.
So we'll continue with the next 3 layers. Next one is network and data link. Okay.
Physical
and
layer.
Physical layer, last one. So first, second, third. So remember, layer 3, layer 2,
We are
and
completed
layer.
application layer now, first of all.
Oh, sorry. We started from here, right?
Yeah.
I'm sorry. Application.
Mm.
Okay. So physical layer, data link layer, network layer.
Mm.
Okay, these three are pending, right? Okay,
Yeah.
we'll complete overview of these three layers today.
Mm.
What is network layer and data link layer and physical layer? What is the functionality of these layers?
Okay.
And tomorrow's session will there are a few more important things. We'll go more deep dive. Okay,
Okay.
so let's start from the this layer 3.
Okay.
So layer 3 is a network layer. Okay.
Okay.
So what is layer 3 instance? See, let me show you some small example. See, this is a PC.
Okay.
Okay. Connected with a switch. Right. Switch to will connect a router
Router.
and router to internet service
Internet
provider.
server provider.
But then wherever the communication will go, right?
Yeah.
Now, this is the layer 3. Understanding about this router concept, how this works. Okay.
Okay.
This is called a layer 3, network layer.
Okay.
And the next one, this is a layer 2. Layer 2 device is a switch. Remember, this is a router. Okay. And there will be few L3 switches also.
Few.
Oh, layer 3 switches.
Okay. Okay.
Okay. I'll tell you what is layer 3 switch, how it works, everything. In routing classes, we'll discuss. Okay.
Okay. Right.
Now, remember, layer 3 device is a router.
Mm.
Okay. And here we use IP addresses.
Okay. Yeah.
Okay. IP addresses and routing protocols.
Yeah.
Okay, routing protocols. Routing protocols, routed protocols, there are few. Okay, IP address, then OSPF, EIGRP, okay, BGP, ISIS, RIP. There are so many things here. But
Okay.
these and all will routing protocol, routed protocol, whatever these we'll discuss in routing classes in detail. Okay.
Okay. Right.
Remember, whenever someone tell layer 3 device, you need to tell that's a router.
Mm.
Okay, so here we use IP addresses, routing protocols to route
Okay.
the traffic.
Yeah.
Next one, layer 2 is a switch. Okay, layer 2 device is a switch. Here we use the MAC addresses.
Okay.
MAC address, there are some protocols actually, CDP, LLDP, and ARP, okay, and STP protocol. There are so many things here.
Okay. Okay.
These and all we'll discuss more in detail in switching classes.
Okay.
Here you need to understand what is layer 2, understanding about a switch,
Mm.
how the
Okay.
switch work, how the data will transfer from switch to this host. Whatever the connectivity we have from the switch to the devices here, the cables or cable or wire or wireless, whatever, this is physical.
Okay.
Okay, understanding about this
Yeah.
is physical layer. So this is the layer 1. Layer
Mm.
2 is a switch. Layer 3 is a routers,
Router.
routing.
Mm.
This is layer 3. And whatever the layer 4, 5 already we have completed
Mm.
up to application.
Yeah.
Right. So when you come here, other side, for example, if you share some data from here over the internet, again there will be some routers and switches and physical devices. Okay.
Okay.
So again, this side also this is a layer 3, right? This is also layer 2. This is layer 1,
Layer
physical.
one. Yeah.
So data will start from here to whatever if you want to share, it come over the internet. Then again it will reach out to layer
Layer
3
two.
to
Layer two.
hmm, and physical devices.
Mm.
But physical, this one application layer session, everything will within your software, whatever the programming will be there, right?
Mm.
Or
Mm.
whatever the application you are using within that software, it will complete remaining three session
Okay.
layer, whatever everything.
Okay.
And coming to this one, whatever the you transfer the data from one end to another end, what we discuss about TCP and UDP. So
Mm.
this will that is actually logical
Okay.
between the devices.
Okay.
Okay. So now we are discussing about layer 3. Remember this diagram.
Okay.
So then we'll go to layer 2 and layer 1.
Okay. Right.
Okay, right. So just try to understand the overview of these layers, how these works. Then tomorrow's class, I'll try to give some more details, some interview questions, I'll show you some practicals. Okay.
Okay, right.
Now, we are discussing about layer 3. Okay. Layer 3 is a network layer. Very important layer.
Okay.
Network layer, right? So in this network layer, so as we discussed previously, whatever the layers we have, seventh one, sixth one, okay, fifth one, fourth, what are the data? Protocol data unit was data,
Data. Yeah.
right?
Mm.
So in this network layer, this data, okay, this data, it takes previously whatever we called here, data to, in session layer it went to segment, correct?
Segments. Yeah.
Data to segment. Next, now we are in third layer, network layer, right?
Mm.
These segments, okay,
Okay.
uh, these segments actually it will convert, it breaks down to packets.
Okay.
Okay, give me 1 minute. 1 minute. One minute, Murli.
Okay.
Okay, sorry, Murli. Murli వినపడుతుంది కదా? Right, Murli. So this data, okay, so data comes into segments come into packets.
Yeah.
So network layer protocol data unit is packet.
Okay.
Okay, remember this. So here, uh, this packets, But what is packets, how it will be there, what is there in that packet, these and all we'll discuss in separate session.
Okay.
Okay, because I told you, right, something called header.
Mm.
Okay, headers, whatever, some in next layer it will come some new feature, actually frame. Okay, about this frame, IP4 address, IPv6 address, these and all we'll discuss separately
No,
because
there
these
is
are very important.
no logo.
Again, logo,
Okay.
why it is coming? Just wait for a few seconds. Now,
Okay. No, right. Clear.
okay, సెషన్ పాస్ చేస్తాను అందుకనేసి ఎట్లా వస్తుంది.
Mm-hmm.
Right, Murli. Okay. So whatever the concept, very important concepts I told you,
Okay.
some headers, okay, TCP, UDP headers,
Mm.
frame, packets, these and all we'll discuss in separate session
Okay.
because these are very important. Okay. So in this layer 3, what exactly will happens, uh, so whatever the data start from application layer. Okay,
Mm.
so
Mm.
after establishing a session, so then the TCP and UDP, what are the protocols we told, based on the protocols,
Okay.
so these will take care the to transfer the data from one end to another end.
Mm.
Now, how data will go from one end to another end, we require some addressing, right?
Mm.
So these TCP protocols are there to carry the data. These protocols will carry the data, but how data will go, right? So we need some destination,
Mm.
right? So this destination is called some IP address, some device.
Okay.
Okay. So
Mm.
how this IP addressing everything will go? It everything, the all the information will be there in a packet.
Okay.
So the main aim of this layer is to deliver packets from source to destination.
Okay.
Okay. So for example, when you're sending a data from one PC to and another somewhere in remote location over the internet. So now this is a source and this is a destination because we are sending from here to here, right?
Mm.
So this is your destination.
Yeah.
The main aim of this layer 3, is sending the data from source to destination.
Yes.
So how the data will go here from one end to another? In a packet,
Within a packet. Yeah.
right? In the
Mm.
packets. But here, uh, there will be so many links, right? For example, if you want to send the data from India to US or US is some any other location, the in between there will be so many links.
Mm.
Okay, there will be so many internet connectivities, routers, internet service providers.
Yes. Yes.
Okay, across this info. But how it will go in which way that will travel, everything we'll discuss in routing classes.
Okay.
Okay, so because in this router we will configure some routing protocols. Okay,
Okay.
something called OSPF, EIGRP, and RIP. No more RIP. We are not using nowadays. There will be some protocols called BGP, ISIS, some protocols. These protocols will show the shortest path to send the
Okay.
data. There'll be
Mm.
so many links, right?
Mm.
For example, if you want to travel Bangalore to Hyderabad, you can go directly Bangalore to Hyderabad in a highway, or you can go to Chennai to somewhere in Visakhapatnam to Hyderabad. You can go.
Mm.
But why should we go these? We have shortest path, right? Who will decide this shortest? These protocols will show.
Okay.
But if you have two shortcut ways, okay,
Okay.
nearest way, the data will distribute. Half of the data will go in a one way, and remaining half the data will go in different way. Because that will distribute, then it will help you to send the data in fast in two ways.
Okay.
Right, these and all we'll discuss in detail in OSPF and whatever routing protocol classes, in
Mm.
routing classes, right? Understand here, the main aim of this network layer is, okay, uh,
Transferring the data from one
transfer the data from source to destination or
destination
deliver the packets from
packets.
source to destination. That is very important point. Remember,
Yeah. Mm.
for example, see, when you connect remotely in a long distance, whatever, in two different networks. So not only long distance, see, for example, see, Here I have a PC, okay, and one more PC I have connected, one and a PC two. These two PCs, if you are connected with a switch, right?
Okay.
I'm
Mm.
connected here.
Mm.
This PC is in 10.1.2.5 network, okay.
Mm.
Uh, Malli is bringing, okay. This is, for example, 11.1.2. Something 10 network.
Mm.
This is in 11 dot network. This is in 10 dot network. So this is a different network, right? Both are two different networks, right?
Yeah, both are
If
two
you
different.
communicate from one to one, there we require a router. Routing we require. Then
Mm.
we'll connect this, a cable here,
Okay.
or whatever the cables we connected like this. Then we need routing. For example, this is the layer one, this is layer two, this is layer three.
Mm.
So data will go from switch to, from physical layer, whatever our PC to the switch to the router. Then router will transfer the data from here to, understand, right?
Yeah, yeah.
So now this is layer one, this is layer two, this is layer three.
Mm.
Got you right?
Yeah.
Now, so for example, if you can assign an IP address, okay, the same network IP addresses in both sides. For example, what I'm going to do is I'm going to assign IP address. So this is also 10.1.5.6.
Yeah.
This is also 10.1.5.7, whatever the IP address host, whatever the subnet mask. If you are adding any, for example, if you add any C class IP address, 192.168.1.10, this is 192.168 dot, okay, 1.15, whatever.
Mm.
Both are same network, right?
Yes.
We use the same subnet mask. So
Mm.
when you connect two devices within a network, so there you don't require any routers.
Router.
You don't require this L3 concept. When if two computers or two systems are connected on the same link,
Okay.
so then there is no need for a network layer. When you have two different networks to communicate from one network to another network, there we require a router. Understanding about this
Yeah.
router, routing, everything is a
Mm.
network layer. This
Okay.
is very important point. Remember this one. Okay.
Okay.
So here, for example, see, it also divides the outgoing message into packets, as we discussed already,
Mm.
and assemble all incoming packets into messages for a higher levels. For example, say, I'm sending a data from one network to somewhere,
Okay.
one to here. So when it sends from switch to router, okay, it will divide into some packets. So whatever you are sending from the data to segments, segments to whatever these everything, okay.
Okay.
These segments, all the segments will divide into packets. All the
Packets.
packets will travel over the internet, right?
Mm.
And it will reach out to here. After reaching out to this router will receive all the packet,
And
okay.
it will convert into segments.
Yeah, I no, 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 it doesn't convert to segments.
Ah,
It will
router.
reassemble
Yeah,
packets.
yeah.
There will be series of packets.
Okay.
One, two, three, four, five, fifth, sixth packet, seventh packet. Everything it will take in series.
Okay.
Okay, again it will reassemble whatever the packets we have divided the information. This information it will send to router to the switch. Then
Mm.
switch will add some MAC information to the destination.
Okay.
Consider this is a switch. Okay, switch to this is a PC.
Mm.
This it will add something called frame. Then it will send to the PC all the packets, zeros and ones, whatever the binaries it will send. So once into come into here, then it will remove these pieces, whatever. So MAC address will remove, then IP address will remove.
Mm.
Then once it is removed, okay, there are some fragmentation, segmentation. I'll tell you that concept.
Okay.
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 So once you this removed, then it will started converting into from packet zeros and ones into whatever we have presentations and everything. So
Okay.
then it will whatever the in application layer will show you whatever the image, whatever information you have shared.
Okay.
So this conversion, everything will happen within your host.
Okay.
When you're sending some image here within your PC, within your software, whatever the software application you are using, so this will divide into some kind of segments into whatever, right? So
Yeah.
whatever the presentation, everything. So then it will go to over the network, and on the other side router will send all the packets to switch will send to the device. Again, within this application, within this software, it will reassemble everything. Then again, it will show you like an image, whatever the image you have sent here.
Okay.
Okay, this is how the data will transfer from one end to another end. But what is the role of network layer is transferring
Transferring
the
the data. Yeah,
packet
packets.
from one end to another end.
Mm.
So we have some protocols to send this, something called ESRP, IPv4, OSPF, RIP. Okay, these devices will take care about the data transferring and receiving.
Okay.
Right, that is called a network layer. So, well, keep it. What is the IP header? Whatever the fragmentation, segmentation, these concepts, I'll tell you in separate session.
Okay, right.
Okay, just understand how network will work. Okay,
Okay.
next one. Coming to this one, maybe you may confuse. What is the difference between transport layer, right,
Yeah.
and network layer?
Mm.
You may have some doubts, right?
Yeah.
Let me clear this. For example, see, when you take a transport layer, this is actually logical communication between a process, right?
Yeah.
For example, process in sense from one end to another end, we are using something called TCP and UDP protocols, right?
Mm. Mm.
TCP and UDP.
Yes.
But when you come into this one network layer side, this is a logical communication between the hosts. That means here it uses IP address, right? One end to another end. For example, source and a destination IP addresses in between whatever the router IP addresses, correct?
Mm.
We require the IP address here.
Yeah.
But when you come here, it doesn't care about an IP address, whatever. It
Okay.
will transfer the data. It will send the packets.
Mm.
So this will process the data. That's it.
Okay.
So this is not responsible to send where. Who will take care about this? The source destination. This
Network layer.
network layer. The IP addresses will take care.
Mm.
Correct.
Yeah.
So here this will send the data from one computer to another computer destination. This is the responsible to share the data whatever from here to here.
Mm.
These protocols will care about only who is the source, who is the destination.
Okay.
Okay, what protocol, how the data is sending.
Okay, right.
But when you come into this network layer, it knows how to travel the data, where to travel the data, what router, what IP address we are sharing, everything it will take care.
Okay.
Correct?
Yeah.
So here, whatever the data convert into segments, then segments here what we use the
Segments.
segments, right?
Yeah.
Here segments. Then here when you come into this, it we use
Packets.
packets. Here we use packets.
Mm.
It doesn't care about what network it is, where
Mm.
it is traveling. It doesn't know. It doesn't care about any whatever the what network we are using, the same network, a different network. It doesn't care. But
Okay.
here the IP addresses should know what network it is going, how it is traveling, whether there is a routing properly configured or not.
Okay.
Correct.
Mm.
So when you come into this one, this transport layer, I told you some protocols, right?
Yeah.
Something called something HTTPS, right?
Yes.
Or HTTP, DHCP, okay, and
Yes.
whatever the DNS or
SMTP.
OSPF, some whatever some protocols, right?
Okay.
Every
Okay.
protocol to identification purpose, there will be one port number.
Port number. Mm.
Okay, but what is the port number? Why port number? Why? How it will work? Everything we'll discuss in routing classes.
Okay. Okay.
Okay, every protocol will have a unique IP address, unique port number.
Mm.
Okay, for example, see to identification purpose, every protocol has one IP, one port
Port
number.
number.
But here, in coming to this one, this uses IP addresses. So network layer uses IP addresses.
Okay.
Transport layer uses port numbers.
Okay. Right.
Here, protocol data unit is segment, and network layer it is packets. This TCP, UDP, whatever the transport layer we are using, it doesn't care about network. It ignores network. Okay.
Okay.
So here we require a network compulsory. Whatever the network configurations we require in network side.
Okay.
So this is about transport layer and
Network
network layers.
layer.
Okay. So next one. So that is about the layer 3.
Okay.
Coming to the layer 2.
Data
Okay,
link layer.
data link layer. So this data link layer, okay, this data link layer actually cut down all the packets into smaller units. We refer to as a frames. See, again, data came into segments, correct?
Yeah.
Now segments came into packets.
Mm.
Now packets will cut down into smaller unit of frames.
Frames.
So these are PDUs, right? Protocol data units.
Mm.
Remember this. So what we need to understand here is how the data is transferring from one into another format.
Okay.
These formats actually we are calling data, segment, packets, and frames. Whatever the actual data image we have, this will cut into the small pieces of information. Those are segments. To this segment, okay, every segment we will add here who is the source IP, from where we are sending, where to sending. Correct.
Each
Understand, right?
seg- each packet.
Yeah, packet.
Yeah.
Okay, so this will cut into packet,
Mm.
and every packet will have who are sending, where we are sending. Okay, what is the packet size? Okay, what is the sequence
E-
number? Whether
Every
it is a,
packet.
yeah,
Every
every packet will have that same information.
same IP or different IP.
No, same IPs.
Okay.
Okay, same IPs.
Mm.
See, for example, you are sending some 10 letters from your home to from your friend home, some office.
Mm.
Every letter, the from address and to address will be the same, right? But you are sending so
Yeah.
many letters. That's it.
Okay. Okay.
You're sending many
Same address. Okay.
same addresses will be there. Same here. Every packet will have who is source, whose destination, which protocol it is using, what are the sequence numbers, checksum, everything will be there.
Okay.
It will travel over the internet, it will reach us to from router to switch.
Mm.
Okay, మళ్ళీ pinging continuously.
Okay. Right.
ఒక నిమిషం మళ్ళీ మాట్లాడదాం.
Yeah.
బిజీ వస్తుంది ఫోను.
నాకు చేసినాడు.
నీకు చేసినాడా?
కట్ అయిపోయింది. నేను లిఫ్ట్ చేయాలా?
ఓకే, నాకు చేసినాడు. హలో మళ్ళీ. network issue ఉంటుంది మనకి.
Okay.
Okay, no problem. So where we stop? Okay, so now we came into data link layer.
There is a logo.
Logo. It will go in few seconds.
Right.
అది సెక్యూరిటీ పర్పస్ వస్తుంది, నో ప్రాబ్లం. ఓకే, సో నౌ డేటా లింక్ లేయర్.
Yeah.
So once the router send the data into the switches, this switch will receive whatever all the packets, everything. Every packets again it will divide into small units that we'll call as a
Frames.
frame. Okay, but what is frame, how it will be there, okay, what information will be there, what is the size of that information, everything I'll share, I'll tell you separate session, because that is very important to understand as a network engineer, and it's also as an interview question.
Okay.
Okay, just understand, it will convert into frames. Frames will send the data to some physical layer, it will convert into ones and zeros, whatever, just understand the concept. Then we'll go one by one details. Okay,
Okay.
see, packets converts into the frame, and every frame there will be some data, whatever the data we are sending, right? The packets. See, this, for example, whatever the binaries will be there, right? So here there will be source MAC addresses and a destination MAC address, who are sending the data from where. Okay, next one, there will be some checksums will be there, for example, whether the frames are sending into a sequence or not. There will be few options, actually some tiles, some different types of concept will be there. I'll tell you in detail in frames in
Those
separate
are the
class.
frames, right?
Yeah, this is the frame.
Okay.
So this frame, from router to in the switch, here the switch will send the data to one, whatever the PC, the
PC.
responsible PC, it will send. So after converting into this, how these frames will convert, from all are ones and zeros,
Binaries. Okay.
binaries. Okay, so it will transfer the data. Now let me come in detail now in data link layer. So as we discussed, the data link layer, whatever the layer 2 is responsible to cut down the packets into, okay,
Frames.
yeah, packets into frames. Now, so these frames, this layer 2 device uses the MAC address, because switch cannot understand what IP addresses, how the IP addresses will work when you
Okay.
connect any PCs. It works based on the device MAC addresses.
Okay.
So the packets will convert into small frames, because and it is easy to transfer the data fastly from whenever you have the small data. Okay, it is easy to transfer the data from switch to PC.
Okay.
Now, for example, router to switch, whatever the concept we are discussing, and PC, right? Now here the interface between to the upper layer, one moment, one moment. Right now,
No. Logo.
again the logo is mute, automatic is coming out, still it's showing,
No. No.
still there is a logo.
Yeah. Still.
What's happening here, man? It will go out. Does
Yeah.
it clear? Okay.
Yeah. It's clear. Now.
Right. Now see, whatever the interface, the upper layer and lower layers. Again, we have two. This layer two divided into two types.
Okay.
Okay. So whatever the communication will do from switch to router, router to switch. Okay, this one. This is called LLC.
LLC.
Okay,
Lower layer. Okay.
logical link control.
Okay. Logical.
Logical link control. Right. So the LLC sublayer, okay, interfaces with the network layer. This is a network, right? L3.
Yeah.
So whatever the communication will happen from here to here, switch to router, router to switch, this is called LLC.
Okay.
And switch to the PC. Okay.
Okay.
So this interface, this communication, whatever happened from here to here, this is called MAC layer.
Okay.
Okay. Media access control. Media access control.
Okay.
This is logical link control from whatever the communication we will tell. LLC, this is MAC. Remember these words.
Okay.
Got it, right?
Yeah.
So what all the other things will happen here in this layer 2 is framing, as we discussed,
Yes. Framing.
right? Framing. So frames are the streams of the bits, right? Bits received from the network layer, L3 layer,
Okay.
right? So next one, these divided into whatever the data, whatever the frames, packets to the frames.
Okay.
And here, number one is framing. Number two, here it uses physical addressing.
Okay.
What is physical address we use here? MAC address.
Okay.
PC MAC address. Every device will have MAC address. That MAC address it use.
Okay.
And also here we have flow control.
Okay.
Flow control. What is flow control means? See, a flow control, this mechanism, okay, a flow control mechanism to avoid fast transmitter from uh, running a slower receiver. For example, say the switch. For example, if switch has a 100 Mbps speed,
Okay.
100 Mbps, for example. So if you have 100 Mbps of speed, for example, there will be some PCs. Maybe this PC doesn't have that much of speed, this port, whatever. So
Okay.
then automatically it will control the flow. It will send the data slowly. Okay. So whatever the receiver capacity we have, it will stop the data and then it will send slowly. That is called flow control, right? We discussed in L3.
Yeah.
Right. So those protocols will decide what is the flow control, what is the speed of network, how much data it will receive end to end. The
Yes.
same concept here also, there will be some concept
We
on flow
discussed that
control.
transport.
Yeah, transport layer. Yeah. Right. So same thing here also, the switch will control the flow.
Mm.
Right. So to prevent the traffic jams, it doesn't send very fast. However, this end device is receiving the data, the speed with this capacity, it will send slowly.
Okay.
That is called a flow control. So that is the reason there will be no buffering or something.
Okay.
Right. Next one. It also controls errors.
Okay.
Error control means, okay, so every frame it will add some kind of trailers here. Then it will add some extra portion of some information. Every frame,
Okay.
okay, every frame it will add something called trailers. I'll tell you, okay, what that I'll show you in some images for that.
Okay.
So it will avoid if it is sending any duplicate packets multiple times, whether it's sending the proper sequence order or not. It will check so that it will control the errors.
Errors. Okay.
Who the data link layer? What are the switches? Right.
Yeah.
Next one. And access control also. What is access control? Access control in sense, see, we are connecting so many devices to the router. Sorry, it's a router, switches, PCs, any IP phones, we can connect. See, from your PC, you can access this router, right? Or you can access some any other applications over the internet.
Yeah.
So this is providing access control.
Okay. Yeah.
So it will convert packets into frames, right? Next one. It uses physical addressing,
Addressing.
mean MAC address. It controls the flow. It will check the errors, error control it has, and access control.
Okay.
These all happens in a layer 2 device. Layer 2 device is a switch.
Okay.
Understand, right? What is layer 2 device, layer 3 devices?
Yes.
So this is how layer 2, whatever the data link layer will work.
Okay.
Okay, I'll tell you some important things about, since we are discussing about something called a frame and packet, right?
Yeah.
I'll try to give some more details here. Anyway, we'll discuss again in detail with practical in future classes, but let me tell a few things. Coming to this frame, okay,
Okay.
frame is a L2 layer protocol data unit. That means data link layer, PDU, right?
Yes.
Frame. But packet, this is L3 network layer,
L3 network layer.
PDU, right? Protocol data unit, number one. Sometime interviews will ask what is the difference between frame and packet. Then you can tell. This is L2 PDU, this is L3
L3.
PDU.
Okay.
Correct. And now here, so this frame comes under data link layer in OSI layer. This will comes under network layer. Next one. The frame includes whatever we connect here. There will be source and destination MAC addresses. Correct.
Okay. Mm.
But here, source and destination IP addresses. Got it right?
Yes.
This packet uses IP addresses, frames uses MAC address.
MAC address.
Correct. Now, whatever the segments we discussed, these segments encapsulated within a packet.
Packets.
Correct? Segments encapsulated into packet, where we need right here.
Yeah.
Okay. Segments encapsulated into
Packets.
packets. These packets encapsulated within a frame.
Frames.
Right. So these are the differences between frame and a packet.
Yeah. Okay.
Okay. Remember these basic things. Just we are looking into some overview, but again we have in detail classes.
Okay.
So that's it about layer 2 device and layer 3. Now coming to the layer 3, layer 1 now, the last one, whatever we have discussed
Physical
now.
layer.
Right, the physical one. Okay, this is the first layer. So this physical layer is the lowest one when you refer into the OSI layer, correct? We started
Yes.
from application. So
Yes.
from 7, this is the lowest one, which one?
Yeah.
The physical one, right? This is the layer is responsible for sending bits from one computer to another to
Responsible.
send the data. This is responsible to send the bits, whatever we call binaries, right? We'll represent with 1 and zeros.
Yes.
Binaries. This is responsible to share the binaries. Next one here, maybe here we can use hubs, okay, because it will send only bits and binaries. Hubs. So we discussed in previous classes, right? So when you connect some PCs to the hub, a hub is not an intelligent device. It doesn't care about whatever the traffic is sharing to here. Simply it will share the data to all the devices.
Yeah.
Correct. How
Hubs.
it will share the data is electrical pulse, zeros and ones. Correct. And when you connect up PCs to a switch, okay, PCs, here we use some plugs, right? RJ45 plugs, that connectors, the data cable connectors, right?
Okay.
So we will connect the plug here on cable. How this cable will carry the data? Again, zeros and ones. That means positives and negatives, whatever we discussed, on and off,
Yes.
right? So physical layer, okay, responsible for, okay, sending the bits from one computer to another computer.
Okay.
But what other things will happen in physical layer is in layer 1, as we discussed the representation of bits, that is
Yeah.
common as we discussed, number 1, zeros and ones, whatever. And the second point is data rate.
It is data rate. Okay.
Data rate means, see, this layers defines the rate of transmission. Okay, which is the number of bits per second. That means
Okay, okay.
how many bits we need to send per second.
Mm. Okay.
Okay, uh, so that will configure how many bits we need to send. Bits transfer per second will configure.
Okay, right.
That is called data rate. I'll show you that in. We'll configure that in when we configure some serial cables. Like I tell you. Okay. Then it will provide some synchronization.
Okay.
Okay, whatever the transmitters receivers will be the right, so sending and receiving. Okay, the sync.
Yeah.
Next, it provides interface.
Oh, we discussed that three-way handshake and that
That is
synchronous.
comes and no, that is different.
Okay.
See, so in three-way handshake we discussed host A to host B. It will send a message, hello, can we talk?
Mm.
Sync message. Then it will send a acknowledgement to sync message.
Yeah.
Then it will send one more acknowledgement. Then
Acknowledgement.
they will create a session.
Okay, okay.
Here we are sending a sync message to establish a session.
Mm.
Correct?
Yeah.
Here, what it will do is whatever the data we are transmitting and receiving from one layer to here, that will sync properly.
Okay, okay.
Synchronization means, for example, something are control the same way. That is called a sync.
Okay, okay. Yeah, understand.
Right? Same here. But that same technical word, but here the concept is different.
Okay.
And the next one you see here, this is it provides interface.
Okay.
What does it mean? The interface is the physical layer defines the uh, transmission interfaces between devices and the transmission medium. That means who is the transmission medium here? We use the cables.
Ah, yeah.
Sometimes we'll use the cable, sometimes we'll use wireless networks.
Mm.
Right?
Yeah, right.
So it provides a interface and it provides some topologies.
Topology.
Topology in the sense the way of device connected. For example, if you can listen, if you can read my previous documents, the basic document, there is a concept called topology. That means, for example, see here I have connected a PC, okay, and one more PC. This PC I'll connect with a switch, okay, and here is a router.
Okay.
Now, see how physically how we have placed the devices. Both are placed in the same place here beside
Yeah.
one to one.
Beside, yeah.
Right, how the communication will start. This is a different network and this is another network, right? So how the data will go, it doesn't go directly here.
Yeah.
We know, we can understand data will
Yeah.
go here, then it will go here, then here, and here come.
Yeah.
So how the devices we have arranged physically, number one, how we have arranged the devices
Physically.
physical.
Okay.
Second two, how these devices will communicate, that is logical, right? Correct, that is the logic.
Yes. Logic.
So understanding about how the devices are arranged physically, how the devices are communicating logically, that is called a topology.
Okay, okay.
Understand, right?
Understand.
Now, so for example, see there are a few computers we have connected. Okay, so we have connected like this.
Okay.
We can understand how this is connected. That is called a topology.
Okay.
Now, for example, if this device want to send the data, it's sent to here, and then it comes to here.
Yeah.
For example, this is 1, 2, 3. This is the fourth one. If one wants to send the data, any data to 4, for example, we configure like this. It comes
Okay.
to 2, 3, and 4. See how we have placed physically, but how this is communicating logically.
Yeah.
Understanding this communication, this connectivity is called topology.
Okay.
Got it, right? So how this topology will decide is how we have connected the network. The connectivity and all where we'll discuss in physical layer 1.
Okay.
Correct?
Yes.
In layer 1 only, right? In physical
Layer
uh,
one.
layer 1 only, right?
Physical
So
layer. Yeah.
it provides topology.
Mm.
Depends on the connectivity, physical connectivity.
Topology. Okay.
Got it, right? So
Yeah.
how we connected?
Mm.
That is important. For example, see, there will be some internet centers will use one bus cable. We'll connect one PC here, one PC here, one PC here, one PC here.
Bus.
But we connected with an centralized device. We'll call it as a bus cable.
Mm.
When this PC sends a data, it will go here and here and here also.
Okay.
But wherever it's sending, for example, if you are sending data from here to here, only this PC will receive the data. These PCs will ignore simply.
Mm.
But physically, how we have connected these, understanding about this connectivity, how we arranged the devices, that is called a physical topology.
Okay.
But logically, how the communication is happening, that is called logical. Correct?
Okay.
We are sitting in Bangalore. If you want to travel to the Kadari, we can travel over the Chintamani, over the Korantla, over the Tumala.
Mm.
We have three ways.
Yes.
But where we are located, understanding about physical things are physical topology. But how we are traveling
Logical. Yeah.
over this road or this road or this road, that is logic, right?
Mm.
That is the logical topology.
Okay. Okay. Understand.
Right, next one. And as you know, transmission mode. So transmission mode in sense how the data will transfer.
Okay.
Coming to this transmission mode, I'll tell you simple things here. Let me take some space. Here we are discussing about the functions of physical layers, what it will do, right?
Yeah.
Now, the last one here, coming to this
Transmission.
one, transmission mode, the sixth one. What is transmission? What are the transmission modes we have is, number one is simplex. Number two is half duplex.
Okay. Okay.
Number three is
I saw
full
that
duplex.
YouTube. Okay.
Okay?
Mm.
Full duplex. What is simplex? When you connect a device one to one, one device only can share the data.
One way sharing. Okay. Mm.
One way.
Okay.
When you have half duplex, the second one, it devices will send one time one PC. For example, when this send the data, this cannot send. Once it is completed sending the data, then it will start sending.
Okay.
These devices cannot send the data simultaneously, but it can send one by one.
Mm.
But here only one device can send the data. This device doesn't have capability to send the data.
Okay.
Next one. Coming to this one, full duplex. At the same time, it can send and receive, both devices.
Okay.
It will send and receive
Both are connected to each other. Okay.
each other, and it will share the data simultaneously. It will send and receive.
Okay.
But here one by one, but here only one side. That is called simplex, half duplex, and full duplex.
Okay.
But how these and all will work is we can configure this in a switch. I'll show you it in switching practicals.
Mm.
Okay.
Okay.
But where it will decide how the transmission is in
Physical
physical layer. Got it right?
Mm. Yeah.
So this is how this OSI layer, physical layer, will work.
Okay.
I downloaded one image. Let me show you that. Right? Can you see this?
Yeah. Yeah.
Okay, you don't have any logo and all now, right?
Yeah.
Cool.
It's clear.
Now, if you can see this image, I hope you can understand what exactly happening here. Right? Let me tell you what you can see. See, now
Yeah.
you know what is physical data network transmission session presentation, everything. Correct?
Mm.
Perfect. So you know the sequence of these layers, name of the layers, you know, correct?
Yeah.
Now, here, when you come into this, in physical layer, there will be cables and hubs,
Yes.
correct? You know that.
Mm.
But what type of protocols works, you know, here? Ethernet. We are using Ethernet cables, right? So, Ethernet protocol will work. If you are using any other cables, then whatever the respective protocol will work.
Okay.
For example, when you use an Ethernet cable, what are the cables in there in it? How the cable will work? There will be some technology, right?
Okay.
So when you are using Ethernet cable, there will be some Ethernet technology. Ethernet protocols will work.
Okay.
Okay. If it is different cable, then different protocols automatically will work. That is about physical. Coming to
Wireless
the
in wireless.
which one? Wireless is a different concept. See, when you are using wireless, that's a good question. Here we are not using cables.
Yeah.
Then there will be electromagnetic pulse.
Yeah. Electromagnetic pulse.
Pulse will share the data. Wireless.
Okay.
Okay.
We have that concept.
No, we don't require that.
Okay.
Okay. So we don't do it with that wireless concept. There is a separate wireless devices and there is a separate course actually. But
Okay.
we don't want what electrical pulse, how that works, and all we don't. We are not doing that. Engineering works right.
Okay. Right.
That is. Now here switches. Coming to the switch, you know what is MAC address? Correct? Physical addresses.
Yeah.
ARP is a protocol to read the MAC addresses. When you
Right.
connect any device, where in which port, which MAC address, which device is connected, this ARP protocol will take.
Okay.
Okay, this NDP, VLANs and all will cover under in switching classes. There we'll discuss CDP, LLDP, these protocols.
Switching classes. Okay.
Yeah, in switching class, there are very big concept for that. We have a lot of practicals, multiple classes for that. There we'll discuss. Very simple. When you have some ports right in a switch, this is completely one network. When you connect devices here, this is completely one network. But here,
Yeah.
a single switch we will divide into logically. From
Okay.
this
Okay.
ports
Right.
into one, this all one switch will divide into different small logical switches. Then we cannot communicate directly from here to here or here to here for security purpose,
Okay.
for maintenance purpose.
Okay.
That
Within the
that
switch.
will
Within the
within a
switch. Yeah.
physically that will be one switch. We'll divide into 3 or 4 whatever we require.
Okay.
Virtual LAN interfaces. Okay.
Lens. Okay.
Okay. There is a separate class and very big class for that. That is very important to practice.
Okay.
Okay. That is about physical and data link. Next one. Coming to the network layer. In network layer, you know, routers.
Yeah. Layer
You
three.
know, IPv4, IPv6. IPsec is a secure protocol we use in VPNs. Okay, that we'll discuss it in separate classes. We have separate for VPN and all. Okay, ICMP and all, whatever we use, ping, some trace at some protocols will come to check the connectivity. These all comes under ICMP. This will cover in routing classes. Why in routing classes? We are discussing here about router, layer 3.
Yeah.
But what is layer 3 switch is, you know what is a switch. Switch
Yeah.
is a device we can connect multiple networking devices with ports.
Yes.
When you come into the layer 3 switches, the same switch has a router. This is a combination of a router and a switch.
Oh, what is layer three
The
switch? Okay.
layer 3 switch. The same device we can configure routing. It can understand IP addresses, routing and all. At the same time, we can connect the devices as well.
It will
This
call
is
the
a
layer three switch.
this is a mixer of a switch and a router.
Okay. Okay.
Switch plus router. That is a layer 3 switch.
Yeah.
But we need to made some configurations, some modes we need to change to use as a switch and router, some configuration. This we'll see in routing classes.
Okay.
Remember layer 3 switch. Layer 3 switch in sense, it's a combination of router and the switch.
Okay.
As you know, we know IPv6, IPv4, what are some protocols we use here. Coming to this one, transport layer. In transport, whatever the transport, there will be no specific device for that. This will happen between the devices. The TCP UDP protocol will help you to carry the data.
Yes.
Correct?
Yes.
And we discussed about what are the differences, how this works, the speed, the slow, whatever, everything. Correct?
We discussed.
Yes.
Yeah.
Yeah. This session and presentation will happen, whatever the process, within a software, whatever the application you are using, the programming. Within your application, it will happen. How it is, session will starting, how what type of presentation it is, whether it is a JPG, video, PDF, whatever.
Yeah.
Right. Next, coming to this one, application, you know the application, right? So DNS, DHCP, FTP, TFTP, whatever this, there are so many protocols,
Okay.
right? These applications will provide the services. These protocols will provide the services. So already we discussed about HTTP, HTTPS and all, correct? DNS and all. This service, this application will utilize. For example, when you use Google Chrome need a HTTP or HTTPS
Okay.
to get to access some data, to
Yes.
interact with the web server. Right? Google itself cannot communicate with this. What are the this one?
Yeah, yeah.
So to get IP address, we need a DNS, correct? So to get these services and all, we require HTTPS.
Okay.
These services, correct?
Yeah.
So this is how we our this layers or 7 layers will work.
Okay.
Got it right?
Yeah, got it.
So this is how these protocols, these cables will include into this layer. Understanding about these protocols devices is called OSI layers.
Okay.
Okay. So is there any other page? Let me go back here. Can you see here? TCP IP models.
World version. Well, versus.
New version. See, TCP and OSI layers. Okay.
Okay.
So, for example, see, as you know, OSI layer has a 7 layers. Correct.
Yeah.
In 7 layers, now there are so many network scientists, some these guys, okay, networking engineers, software, everyone will there. Few people don't like OSI layer. They'll say this and all complete bullshit. Reading about that, these and all. We don't want 7 layers. The 4 layers is enough. Few people will define like this.
Okay.
Few
Okay.
people will come. No, not 4. We can if we can divide into 5 parts, that will be fine. There we can understand it clearly. Few people will support OSI. Right.
Okay.
So when you come into this practically, see the devices will communicate from the application to it goes to transport to network to
Network.
layer 2 and
Layer.
device. Correct. 1, 2, 3, 4, 5 only. When you
Yes.
come into the practically, so there are only 5 layers is enough to
Okay.
understand this concept, right? But if you can divide into again what happens in this device, again 2 more extra layers
Yeah.
will add. That is
Yeah.
OSI.
Okay.
But
Right.
communication, understanding, everything is same. But however you want, you can use. But when you come into the practically, we use an application. Okay, we are transporting some image. Okay, and here TCP or UDP will work.
Okay.
So then network we required. Whatever the
Yes.
IP addresses, routing protocols we required. Okay, now this will come and reach to the data link. Here MAC address will work.
MAC
It
address
will
will
send the
okay.
data to physical.
Mm.
Again, another side, it will reach out to another physical device and it reads about MAC information. Then what are the network information it will remove. Then what are the image that will show again here.
Okay.
So the same concept we'll understand within a 5 layers. That is called TCP IP. When you are dividing these concept into 7 layers, that is OSI.
Okay.
Correct. So now, previously there are only 4 layers in TCP IP in old model. Now, newer layer we have 5:
Yes.
physical, data link, network, transport, and application. Whatever the here application layer, okay, application layer, presentation layer, session layer will include within application only.
Yeah. Understand.
Okay, that's 3. Whatever the top 7th one application, 6th one presentation,
Presentation session.
5th one is a session. These 3 includes within here only.
Okay.
These all are common. The same TCP/UDP, same concept, same password, whatever the functionalities, everything is segment. Okay, you see here data, segments, packets, frames, and
Frames.
bits, and bits.
Okay. Right.
The PDF, the same concept will be the same, but just
Yes.
we are using here only 5 layers to communicate to understand about the uh, this OSI layers. Got it right?
Okay.
So
In the interview purpose, what will he ask?
I'll tell you that I'll tell you what to prepare, how to prepare, what they will ask. Okay,
Okay.
just try here all the applications. These divided into one, and remaining are same.
Okay.
When it was an old model, data link and physical they used to mix it as a network interface and all, but no, we are not using this now.
Yeah. Got it.
Remember, OS level has 7 layers. TCP IP has only 5.
5.
What are those? Just physical, data, network, transmit, and application.
Yeah.
Okay. Now coming to your question, the interview and all. See, interview is depends on the interviewer.
Okay.
That means I'm not stopping now. Only with that word. How interviewer? For example, if I am an interviewer, when I take interviews for fresher or whatever the internet network engineer,
Okay.
what I'll tell you, I'll ask the first question.
Yeah.
Do you know what OSI layer or TCP/IP? Okay,
Yeah.
explain yourself.
Mm.
That's it. My question.
Okay.
So then I listen how these guy will explain.
Okay.
Explain about OSI. He'll start from okay OSI and TCP. OSI has the 7 layers and TCP has 5 layers.
5 layers.
But coming to the logical, whatever the concept we are discussing, communicating, everything is same. But we are understanding the how the device is communicating from one end to another end. So we will divide into 5 layers in OSI in 7 layers.
Mm.
In OSI layer, we have 7 layers. Okay, it start so physical layer, data link layer, network layer, transport
Transport
layer,
layer.
session layer, presentation layer, and application layer.
Yeah.
Correct. So in coming to this TCP application and session layer
Trans.
and the presentation, these three comes under only application layer.
Mm.
Remaining are same: transport, network, data link, and whatever the physical. These are same.
Yeah.
Now application layer. What is application layer? I'll tell some devices what is application layer, how it works, what protocols will come. For
Mm.
example, then this is how I'll explain one by one, one by one.
Okay.
Once you are able to explain this way, what
Yeah.
application will do, what network will do, what IP address will come, what TCP and UDP.
Mm.
When you tell this completely one by one in front of the interviewer, then automatically he'll get to know, okay, this guy knows how the devices will communicate, how
Yeah.
network will work. Okay, that's fine. You get a point.
Yeah.
Positive marks.
Okay.
That is overall question. Sometimes they will ask you direct question, what is difference between TCP and UDP? Then you need to explain about only that.
Mm. 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 Yeah.
Okay. What is encryption and decryption? In which layer it will come? They'll ask.
Yeah.
Right? So sometimes they will ask about what is frame and packet differences. Okay, sometimes we'll ask explain about some session layer or protocol layer.
Yeah.
Something whatever the protocols about some give me some examples of application layer protocols. Then you can
Okay.
tell what is DNS, HTTP, HTTPS, whatever you can tell.
Okay.
Sometimes they will ask what is use of physical layer. So how the data link will come? Where our protocol will be there? In which protocol will come? Where CTP will come?
Yeah.
So this is what they will ask.
Okay.
If you can read whatever we are discussed today, yesterday last class and today's class completely about OSL layer.
Mm.
If you can prepare completely,
Mm.
then automatically you can answer everything.
Yeah. Sure.
So just you need to read overall concept.
Yeah. Okay.
Okay.
Mm.
So that is an overview of OS layers.
Yeah.
In the next session, what we will discuss is I'll add few other concept in OSL. The same concept only, but I'll take one frame. No, no, not frame. Headers will take. What header? How it will works. Okay. What is TCP UDP headers? What will be there in it? What is the meaning of it?
Okay.
Okay. So what type of questions we have in OSL layers? So I'll tell you some new concept. I'll show you some practicals tomorrow.
Okay. Right.
We'll create one topology in packet tracer. We'll add some devices. We'll try to send some packets one into another end.
Mm.
The same OS layer we'll try to open. We'll see that. I'll show you that tomorrow.
Mm.
There you'll understand more in detail. Okay.
Okay. Right.
Okay. Just go through with that. I'll share you that. I have some document about OS layer. I'll
Well,
send you whatever we discussed. Prepare with that.
okay.
Okay. Ready with overview, some knowledge of this OS layer. Then we'll go
Okay.
through some practicals. That's it.
Sure.
Okay. Fine, Murli. We'll meet you tomorrow. Right. Bye.